Welcome to the PV power plant module. I'm Professor Mohammad Reza Aghai, the coordinator of the module, and I'm delighted to introduce this module along with its courses. Before delving into the details, I would like to provide an overview of the current state and the future prospects of the solar photovoltaic energy, as well as its pivotal role in the global energy transition. Solar photovoltaics is the foremost renewable energy technology for cost-optimized climate change mitigation and a smooth energy transition to provide clean and affordable energy based on the Sustainable Development Goal number 7, which ensures access to affordable, reliable, sustainable, and modern energy for humans. However, achieving this scale of deployment poses significant challenges considering the resource constraints, technology limitations, integration into the existing energy systems and grids, and ensuring their reliability, security, and flexibility. Meeting the ambitious Sustainable Development Goal number 7 and a climate-neutral economy requires massive PV installations ranging from 20 to 80 terawatt peak by 2050. And further expanding from 80 to 170 terawatt peak by the end of the century in progressive global energy scenarios. Despite the remarkable milestone of more than 1 terawatt peak global installed PV capacity having been reached in the beginning of 2022 and the continual cost reduction over the time, PV still remains only a small fraction of the global electricity generation, contributing only 4 to 5% in the last years. However, accelerated PV deployment coupled with the deep electrification has the potential to deliver significant CO2 emission reductions amounting to approximately 21% or nearly 4.9 gigaton annually by 2050. This further emphasizes the importance of pushing the boundaries of the PV technology and implementation. Ensuring a smooth transition and managing this demand surge requires strategic planning and coordinated efforts. These escalating statistics clearly illustrate the requirement for a marked surge in PV installation with the gigawatt power capacity and vast amount of electricity generated in the terawatt hours. Before introducing the module and its interesting courses, let's provide a concise overview of the PV power plant. Generally, PV power plants, so-called grid-connected PV systems, generated AC power for various applications beside the electricity supply for grid networks. PV power plants are classified into small-scale PV systems, which is between 1 to 100 kilowatt peak, which are used for the commercial and residential applications, and also utility-scale PV systems, which is over 100 kilowatt peak, typically ground-mounted systems that supply the electrical power for urban and industrial applications. However, it's worth mentioning that PV systems have been diversified in terms of the application in different industrial sectors. This includes integrated photovoltaic systems that represent a cutting-edge approach to solar photovoltaic energy generation, combining the benefits of the solar PV power with the innovative design and integration techniques. These systems are characterized by their seamless incorporation of the solar panels into the building structures and infrastructure or other surfaces, enabling efficient energy generation while simultaneously serving aesthetics, functionality, and also architectural purposes. As a few examples, I would mention to building integrated photovoltaics, as I explained to you, floating PV, agrivoltaics, vehicle integrated photovoltaics, and so on. However, the focus of this course is not on integrated photovoltaic technology, but the contents are very relevant for their project planning and engineering, implementation and construction, commissioning and operation and maintenance. The PV power plant module is designed to provide students with a comprehensive understanding of the entire life cycle and aspects of the photovoltaic power plants, from initial development and construction to operation and maintenance. This module encompasses three key courses. The first course dealing with the project development, the second course dealing with the engineering, procurement and construction, and the final course is about the operation and maintenance, each focusing on distinct phases of the PV power plant life cycle. The project development course serves as a foundation of the PV power plant module, offering students insight into the early stage of the PV project planning and implementation. A student will explore the technical, economic, and regulatory aspects of the PV power plant development, including the site selections, solar resource assessment, site analysis and environmental impact assessment, financial and feasibility analysis, permitting, and stakeholder engagement. Through case studies and practical exercises, students will learn to navigate the complex landscape of the project development and understand the critical factors that influence the success of the PV initiatives. This course is co-facilitated by myself and Professor Kilian Labuto from the University of Lisbon in Portugal. The EPC course delves into the engineering, procurement, and construction phases of the PV power plant projects, where the theoretical concepts are translated into the tangible infrastructure. A student will learn about the design, procurement, and installation of the PV systems, as well as the project management, quality control, and risk management principles. Through hands-on simulations and real-world scenarios, a student will develop the skills necessary to oversee EPC activities, manage the project timeline and the budget, and ensure the successful execution of the PV power plant projects. This course is led by Dr. Marilia Braga and Professor Ricardo Guter from Universidade Federal de Santa Catarina in Brazil. The O&M course focuses on the post-construction phase of the PV power plant operations, where ongoing maintenance and performance optimization are essential for maximizing energy production and ensuring long-term reliability. A student will explore various O&M strategies, including the preventive, corrective, and predictive maintenance, troubleshooting, performance monitoring and data analysis techniques, quality assurance services, repowering, inspection tools, and also failure tapes and mechanism, advanced monitoring standards, and financial aspects. By studying industry best practices and emerging technologies, a student will learn to identify and address operational challenges, minimize the downtime, and optimize the performance of the PV power plant throughout their life cycle. This course is facilitated by myself and Dr. Eduardo Sarquis and Dr. Bjorn Muller from Enmova company. Last but not least, through the PV power plant module, students will gain practical knowledge and valuable skills that are highly sought after in the solar photovoltaic energy industry. They will benefit from the hands-on learning experiences, industry insights, and networking opportunities that will prepare them for successful careers in the growing field of solar energy. By mastering project development, EPC implementation, and O&M management, a student will be equipped to contribute to the advancement of the sustainable energy solutions and make a positive impact on the environment. In the end, as we dive into the PV power plant modules and its courses, I urge you to approach your studies with the curiosity and determination. Remember, you are not just learning about the photovoltaic systems and power plants. You are joining a global movement towards the sustainability. Embrace challenges, seize opportunities, and let your dedication drive you toward success. Welcome on board, and let's make a positive impacts together in the energy transitions. Thank you.